This is Math 139, Section 1.2, Part C. We're going to be looking now at using graphing technology to analyze our functions. And there are two good ways to do this. One would be a graphing calculator like a TI-84 or perhaps a TI-Inspire. You can get these free on your Android phone from the App Store. There's a small, I think, $5 fee on an iPhone if you don't already have a standalone calculator. And then the other way is to use the free Desmos application. You can just download it free on your computer. It's just desmos.com. Because my calculator doesn't show up real well on this document camera, I'm actually going to do our demonstrations on the computer using Desmos. And I would encourage you to follow along. It's a really nice tool for doing these kinds of things. So we're going to be analyzing the function x cubed minus 3x squared minus 45x plus 20. Okay? And we are specifically right now going to do it on Desmos. Oops, sorry about that. Let me fix that. There we go. All right, I'm going to go to Desmos. And you'll notice again it's just desmos.com. And the first thing I'm going to do is go ahead and input my function. So we chose to call our function g of x, or at least that was what was in there. And Desmos does understand function notation, so I can type it in just like that. G of x equals, and it was x cubed. I'm just using the little caret key above the 6 to get the exponent, minus 3x squared minus 45x plus 20. All right, I sort of kind of have a graph of my function over here, but I'm not seeing much of it. So there's a number of different things I can do. I can just zoom in or out, or I can try and control the actual window values myself, like I might on a calculator. Maybe right now I'll just go ahead and say zoom out, just get a little bit better picture of this. And what I'm noticing is, gosh, it's getting awfully tall and skinny. I really don't need to see all of these x values. So maybe I will go ahead and keep the big y values. I need to see really high and really low, but I don't need to see so much of the x-axis. So in my graph settings, I'm just going to take my x-axis and set that to -10. Oops. -10 to 10. There, that's a bit better. Now I still don't quite have as much as I need on the y-axis. So let's look a little bit more there. I'm close, but not quite there. On the y-axis, I was at approximately -190. Maybe I'll do -200 and +200. And just see what that looks like. Okay, maybe I didn't need to go quite that. Oops, what did I do? 2,000? I did. Sorry, -200. There we go. And that's pretty good. I can now see my graph in a reasonable window, the way I'd like to see it. The first question that we were asked in our worksheet was, what is the domain and what is the range? As I look at this, the domain would be all real numbers. I could put any x value in, any x, and I'd be able to find a y. Right? The x's go all the way from the left side to the right side. Similarly, the range is also going to be all real numbers. This side is going to take care of all the negatives, keeps on going down towards -infinity, and this side keeps going up towards +infinity. So, my domain goes from -infinity to infinity, and so does my range. All right, the next thing I'd like to find is g of 2. So if I go back to Desmos, I can actually ask Desmos to find g of 2. I type it in using my function notation, and notice there it is. Told me -74 right there. Next, we'd like to find x so that g of x equals 61. I have a little bit more work to do this time. because I can't very easily estimate 61. It's going to be somewhere, this is probably what, 20, 40, 60. Yeah, 61 would be just a little above here. So it's somewhere in the neighborhood of -1, but I don't know if that's exactly right. The best way for me to get Desmos to tell me this is to put in y equals 61. It's just a horizontal line. And then I'm going to notice that there's actually 3 different places on the graph where y is 61. One is right here. And if I just click on it, Desmos actually tells me what the x value at that location is. So x is about -4.708. I'll show you my work over on the paper in a minute, but I'm jotting it down as I go. There's another spot right here, and our guess was right. At x equal -1, I also have a y value of 61. And then there's one more place way over here. When x is 8.708, y is 61. Now that's probably a decimal approximation, but 3 decimal places is usually good enough accuracy for what I'm going to need. So I'm happy with that. And I've just listed those x values that we just found using Desmos in my worksheet. The next thing we're asked to find is local maximum and local minimum points. Once again, on Desmos, this is as easy as a click away. Right here, I've got the top of a hill. So this is a local maximum, and if I just click on it, it tells me that point is -3,101. So I'm going to list that as my local maximum on my worksheet. The local minimum point, the bottom of the valley, is right here. Again, if I simply click on it, it tells me that point is 5,-155. And again, I've simply listed those in x, y coordinate form. All right, I now want intervals of increase and decrease. So as I'm looking at this, and let me just kind of click on the graph to erase everything for the moment, I'm just going to label my maximum and minimum. Those are going to be important. And I'm actually going to get rid of this. By the way, all you have to do is click in this little circle, and I didn't actually make it go away. I didn't use the X to get rid of it, but it doesn't show up anymore. One other little trick, if you hold down, you'll get a choice of colors. So for example here, if I wanted to change my graph to red to make it a little easier to see, I could do that. All right, so once again, I'm going to get the maximum point to show up and the minimum point. And I'm going to notice that this graph is going up. It's rising until we get to x equals -3. So this graph is increasing from -infinity until -3. That's an interval of increase. There we go. All right, the graph's now going down for a while. It goes down from x equals -3 until we get to x equals 5. So that would be an interval of decrease. From x equals -3 to x equals 5. Finally, oops, I need to go back to my previous settings here. There we go. This, by the way, is like a redo or an undo over here. It goes back to my previous settings. From x equals 5, and then from there on forever, the graph increases. So from 5 to infinity, I would have an increasing graph again. So I'll list that as an interval of increase. All right, the last few things we're asked about are the intercepts, or zeros. And the X-intercepts, if I come back over here, the X-intercepts where we cross the x-axis, once again, point and click, it's as easy as that. There's an X-intercept at -5.628, 0, I'm listing these on my worksheet as I go. There's another x-intercept over there at 0.434, comma 0. And then the final x-intercept is at 8.194, comma 0. All of the places where the graph crossed the x-axis. And there they are listed. We'll go back and get the y-intercepts in just a minute, but while I'm here, the x-intercepts, the x values themselves, are really the zeros of the function. They're the x values that make y equal to 0. So the zeros would be negative 5.628, 0.434, and 8.194. Once you have the x-intercepts, you automatically know the zeros, and really once you have the zeros, you automatically know the x-intercepts. They're very closely related. All right, let's just go back and get the y-intercept. Oops, I keep doing that. There we go. The graph only crosses the y-axis once, right there at 0.20. And notice that if it's truly a function and passes the vertical line test, it can only cross the y-axis once. Y-axis is a vertical line. So 0.20 is my y-intercept. So as you'll notice, and if you haven't used Desmos before, you're probably, hopefully at least a little bit impressed. So much of Desmos you're able to simply point and click to get information about a graph. As we go on in this course, we'll be discussing many different families of functions. In fact, polynomials, linear, quadratic, and higher order ones, exponential functions, logarithmic functions, rational functions with algebraic fractions, and radical functions, square roots, and so on. As you go through the course, one piece of advice that I would give you is try to organize your thoughts around these function families. Functions within the same family share similar characteristics. So all exponential functions, for example, will have similar things about them. And you'll want to kind of group them together in your mind. Similarly, all rational functions will have certain things, certain characteristics that they share. And you'll want to group them together in your mind. The graphs themselves will really reveal a lot of those characteristics. And so what we've just looked at is going to be helpful as we move forward. This concludes section 1.2.